the first question that people in the industry started asking was like, well, why is there so much corrosion now? And why do we need to put this fancy? And the answer simply was, historically, you were using Schedule 40 pipe. And that takes a long time if it'll ever corrode all the way through in a dry system. So really, these corrosion preventative measures are just Band-Aid for using thin wall pipe.
This is episode 94 of the Fire Protection Podcast, powered by InspectPoint. I want to welcome my guest, Ray Fremont from General Air Products, onto the podcast today. I've been friends with Ray for a long time, known him from way back in my Tyco and Viking days. And I haven't had him on the podcast in a while. We kind of get into it pretty early, so please listen in. It's kind of a little funny story behind the first time he was on. Anyway, I want to get more in like what they're doing at General Air, but mainly just dry air systems in general, and not dry air systems, but dry systems in general, and how kind of solutions have evolved over time. And, you know, it's one of the big problems in fire sprinkler is dry pipe valve systems. So, you know, they have some great products out there and kind of cool ideas coming forward. So it was great to catch up with Ray, and excited to hear the feedback from the podcast today. So thanks again for listening, and see you again soon. Ray, I finally got you on the podcast. I know a lot of that's my fault for not inviting you, but
I was like, what do I got to do to get on this thing, Drew?
Actually, you were on a podcast, and I was actually going to talk about this. It's going to surprise you, but you were on a live podcast in San Antonio. Do you remember that?
San Antonio was, yeah. Vaguely.
It was one of the first ones.
Was I?
Yeah.
Okay. That's very cool. I was,
what's funny?
When was that?
Yeah. That was NFPA in San Antonio. And my idea, you know, we were still young in the company. My idea was to get all these different parts of the industry talking about nitrogen, air, engineer's perspective, contractor's perspective.
That's right. You know, I remember that now.
We did it at a tequila
like a Mexican
bar.
Restaurant.
I wanted to get everybody riled up and fighting. Yeah. And what came out is everybody was hugging each other and agreeing with each other at the end of the day. So it was like,
this isn't great for my podcast. This is terrible.
No, I wanted to fight.
That's right.
So you have been on the podcast before.
That's right. I remember that now. I remember that very much, actually, because I was not looking forward to that either. I was like, oh man, am I going to have to go in here and argue with everybody? Because when it comes to especially nitrogen, we're certainly the black sheep of that group. So yeah, and we're before vapor pipe shield. We were before, you know, even back then. I mean, that was I don't know. My line for that is that nitrogen generators are inefficient air compressors. So that concerns me. You know.
Yeah. Well, before we get into like the comparison, let's like people might not know who we are. Like tell the audience who we are and kind of what General Air Products is about.
Absolutely. So my name is Ray Fremont. I'm the president of General Air Products. General Air Products has been supplying air supply solutions, primarily air compressors, to the fire sprinkler industry since the 1960s. We've been in business since the 1930s. We're actually celebrating our 90th year in business this year. So that's really cool, right? And it's a family-owned business. So it's my family's business. My great-grandfather started it in the 30s. My grandpop helped develop our first, not helped, he designed and developed our first fire protection air compressor. My dad and his brothers ran it for years and started working with distribution and spreading it across the country and everything as the industry was kind of growing up. And, you know, ultimately that's where you and I met when you were at Viking and I was running around selling air compressors and stuff like that. And so it was a byproduct of my dad's efforts there. And then presently me and my brothers are running the company. So it's been 90 years, like I said, and it's just a lot of focus on a very niche aspect of the fire sprinkler industry. So, I always try to tell everybody like, hey, I'm very proud to say we know a lot about what we do, but we also are very aware of what we do fits into a sliver of what everybody else has to know about. So it's not really much of a brag.
A niche within a niche within a niche, right?
Yeah, very much so. Yeah. So it's,
But
but yeah,
I think, dry pipe systems out there on the sprinkler side, right? We're talking sprinkler today on the podcast, but like dry pipe sprinkler systems have been around for over 100 years, right?
I know of them in the 1940s, but I think that they predate that. I mean, I think it was 1940s when they really started to show up more. I think the
Yep.
dry valves as a invention were before that, so probably about 100 years. But it was during a big manufacturing boom during World War II that you started seeing more and more manufacturing plants that were putting in fire sprinkler systems, and they required a dry system solution in those. So. That's my understanding of how it really kind of took off there.
Yeah, I remember when I worked at Viking, ran in. Somebody sent me a picture of it, but it was a Titan. It was like a Viking Titan drive. It was something from the 40s, and it still worked. It was wild, that it still works. And I can't say the same about newer dry valves. Some are great, some are great. I mean, I started my career with the Tyco DPV1, manufacturing it in like the early 2000s. So it's kind of crazy that I'm talking to this about 23 years later, on this about similar issues from 23 years ago with, water delivery time, leaks in the dry side, and corrosion and all that. And I know that's where your expertise is. So
yes, yeah, in this industry, you can run all the way to the forefront of the cutting edge of this industry where Inspect Point is at and where you operate, but you'll never get away from some dry valve issues, at least for a while anyway. I don't know. But
yeah, it's still a mechanical device.
It's a mechanical thing.
That's
exactly it.
Yeah. So you have, just to explain to everybody, I'll explain the dry pipe side and you can go from there, or the valve side. So yeah, you're in an unheated space, unconditioned space where, water has potential for freezing. So you have this valve that holds the water back until it's needed for a fire. A head or two pops, activating the system. From there, there's essentially air, some type of air or gas fluid holding that valve closed until those heads go off, and then releasing water into the system to put out that fire. So, I think one of the large, I don't know, it's probably a top 10 issue, I would say, in fire sprinkler is maintaining that air and keeping that pipe network, which is all the time on dry systems, metal, right? It's steel. So keeping that from corroding. And I know we've seen that over the years, and you guys have solutions for everything there. So I'd love to kind of hear, maybe not about your product specifically, but like just in general, like, hey, what are the different options?
Yeah. So, it does come back to the metal that's used. I mean, again, people, when, nitrogen first came out about 15, 20 years ago now, I think it's actually closer to 20. I should say nitrogen generators. Nitrogen had been used for some time, bottled here and there. It wasn't prevalent by any means, but it was certainly used. And then the idea of using generators came about. But the first question that people in the industry started asking was like, well, why is there so much corrosion now? And why do we need to put this fancy? And the answer simply was, historically you were using Schedule 40 pipe, and that takes a long time if it'll ever corrode all the way through in a dry system. So really, these corrosion preventative measures are just a Band-Aid for using thin wall pipe. So it's, and it's like, and that's a little bit, critical or cynical, but ultimately we're trying to build sprinkler systems that are more affordable and operate properly.
Yeah.
So if you can, take that cost out of the piping and apply something like a corrosion mitigation solution that will make the pipe last as long as Schedule 40 pipe did or longer, then that's what you're looking for as an industry.
It was funny that you say that, because so after I forget about this my early career. So after I worked on the Tyco dry valve, I moved around within Tyco, but then ended up at their sprinkler pipe mill in Arizona, making XL pipe, which is Schedule 7, I think Schedule 7, and Schedule 10, right? And it was crazy, the solutions that they were trying to. 7's like paper, not paper thin, but it's super thin. And people were buying it because it was super cheap, and it was still, allowed in the code or whatever. I don't know if it still is, but, and then Schedule 10, they would put this ABF coating on it, right, to prevent corrosion. But it was a total marketing technique, because the way they put it on, in a lab, they'd put it on and it would stay on. But when we were making pipe, they would put this ABF supposed fluid on, and then they would just drench it with water to cool the weld where the pipe weld came through. So all that fluid just washed off. And so back to your problem of all these leaks with Schedule 10 and even 7, it was just trying to cut costs. And I don't think the industry, and not the industry, but certain manufacturers were doing it correctly. So I don't care if I out them at this point. It's 20 years ago. But anyway, it's kind of funny that we're talking about that now.
Yeah, I mean, those decisions there had implications that go into the future. I mean, these things are built into these buildings, and they're meant to last a long time. You don't want to be replacing them. So I think, at the advent of that concept of using more and more thin-walled pipe, there was a lot of good ideas and there was a lot of bad ideas. And over time, it plays out. I mean, and it's got to be a frustration for people operating at the in the industry where it's kind of much more technological, how slow things go. I know even from where ours, but again, these things take place over time. I mean, you can't, it's just, you don't make a lot of changes to something that's so important quickly. And the way that you measure something good, bad, or otherwise is over time in a way that you can't really speed up. So I know we run into that frustration quite a bit as we test a lot of product and some of the things that we do. It's I'm sitting there going like, hey, when can we get some answers on that? It's like, well, when the test is done in a year, all right, but it is what it is.
So you talked about nitrogen. What it like, and we got to hold this water back in a dry pipe valve. So you mentioned nitrogen. What are the other, options out there for these systems?
So obviously the most common is compressed air, and that was used historically. And the big change there is just, again, going back to the 40s when dry valves were made, back in these manufacturing spaces, people would run a line from their plant air compressor to the sprinkler system, right? But they, and again, trial and error showed how these things took place. There was, say, 100 or 200 horsepower air compressor that did all the air lines in some manufacturing facility, and then they'd run a line to the sprinkler system. Well, the problem there is, that air compressor will keep up with every popped head on that dry system, right? It'll just look at it as leaks and just keep running. So that's where air maintenance devices came in, right? So it was pull back pressure and flow so that, you didn't have that issue, right? So because we had two things to meet, right? 30-minute fill and 60-second water delivery time. Well, you're going to get, if you have a big enough plant air compressor, you're not going to get any, that valve will never open depending on, certain situations. So you had to make sure that you had reduced flow and reduced pressure by way of an air maintenance device. So that's why that was a listed component that was in front of the dry valve. It was for that reason, for plant air and things like that. But then, plan air running that, like these big companies after a while realize, I don't want to run my 100 horsepower air compressor for 30 seconds, over a weekend and stuff. It's a lot of wear and tear. It costs money, and that's so vital to what's going on in my manufacturing facility. Why not just buy a small air compressor and put it onto this dry system? And that's where individualized air compressors for these systems started to come in. It was something that my grandpa saw because he was doing designs for buildings. It's actually cool. We have some in our building. I have some of his handwritten drawings from like the 1940s of all of these air systems. And then you can see actually as I was going through them, like all of a sudden and it was like the early 50s, he's doing these designs for like soot blowers and boilers and things like that. And they were like, hey, you're the air guy. We got to do something with this dry system. We need something there. And he started putting air compressors in there and everything. And then at a certain point, he said, I can design this better than, these ones out there. It's a different application it's more flow oriented than pressure oriented. So anyhow, that's, so air has been the primary way to pressurize these systems for the longest time. And then, like I said, certainly nitrogen came into play. I want to say in the 80s in bottled nitrogen, you started to see some applications of that in the 90s. And that's still not a bad application if you're doing a small system, it's well maintained. You just don't want to be putting bottled stuff on a system where you're going to have to change it out all the time, or else you're going to run into problems.
Right. Yeah, a lot of leaks.
And then, like I said, nitrogen generators came along. And before that too, there was a need for dry air for cold storage applications. So that was in the 90s where, you started
ice plugs
seeing
and stuff, right?
Exactly. And we had conversations in the mid 90s with FM. They were looking at their insured buildings burning because they had ice plugs. There was no water getting to these and they decided it was ice plugs, and what can we do about it? And we started with our dry air units that would eliminate ice plugs, and we still make those. Like I said, then later you have nitrogen comes into play to reduce corrosion. And then most recently, we developed a vapor corrosion inhibiting product, which uses a different gas technology in order to mitigate corrosion. So over 100 years, we've taken 3 steps.
Right.
That's about my pace, so I'm good with that.
The industry doesn't move fast, and I mean, over the last 20 years, I think it has, right? With dry air, nitrogen, now vapor shield, and things that are coating the pipe. So is that what vapor shield is? Is it coating the pipe for corrosion, or is it acting as? So you use that in combination with just a regular air compressor.
You use it in combination with a regular air compressor. So it's a gas that comes off of a powder. So it is gaseous. Coating is it's weird. I'm always concerned with the use of the word coating, because people think about like some sort of spray on coating or something that affects the internal diameter of the pipe or might flake off and break or something like that. That's usually the common conception around the term coating. And this product is not that. This is a VCIs, or vapor corrosion inhibitors. They're also known as volatile corrosion inhibitors in that they're molecular and they move around, but they find spots on the metal substrate where they're electromagnetically attracted, and they sit there once, and then they kind of there's 2 important aspects to them. They're hydrophobic, so they're pushing away moisture from the metal. So really, when you think about the corrosion triangle, oxygen, metal, and water, you're taking metal out of the equation. You have a 1 molecule barrier between there. And so when you're pushing the water away, you're pushing any corrosive elements away from the metal. Again, on a molecular level. So it's and then the other aspect is that they repel other VCI molecules. And that's where the coating thing comes in, whereas it never gets to be more than 1 molecule thick. which is you know what I mean. So they can't stack on top of each other. I always use an analogy with a parking lot. It's these cars are looking for a spot, right? Just like these molecules are looking for a space on the substrate of the metal, and once there's a molecule there or a car already in that spot, they just keep going down the road until they find an open spot to sit.
Right. So this product, obviously compressed air and nitrogen are in NFPA 13 / and as well as 25. Is Vapor Shield there yet with some of the sprinkler codes?
Yeah, it's in NFPA 13. It's equivalent to nitrogen. So there's a 120 C factor associated with the use of it. Yeah. So, and then there's definitions for what a vapor corrosion inhibitor is. And there's a series of things that you have to do to use it. You have to use it from a listed source and things like that are in NFPA 13. This cycle in NFPA 25 will just introduce something about, using, if you're using vapor corrosion inhibitors, to follow manufacturer's instructions for the maintenance of that product.
Well, yeah, and I'm glad you kind of pushed that through, because it took NFPA 25. I don't know. I thought, when we started in Spec Point, I was like, oh, air compressors are in 25. What's that? And we added it, and they weren't when we up until a couple cycles ago. And I'm like, these things have been around for 80 years or 90 years. So this is wild that they're not in NFPA 25, and they finally put them in. So I'm I'm glad the Vapor Shield and VCIs are moving into the maintenance side, because it's probably a pretty big maintenance item. Am I correct?
Yeah, I think that's the one place where it gets the most attention. I mean, when people are designing systems, traditionally, and I always give the designers I call on grief about it, but they just put like a rectangle that says air compressor. And, they have this beautiful design for the whole system, and there's this and it's like, come on, guys. So we have, drawings for that now and everything, but that was kind of I think spoke to the consideration that the air compressor has on the design side. And it's just all of a sudden, oh, we just need one. But then once it's in there, yeah, it's the thing that makes the dry system work, and you could argue that, okay, well, when it trips, it works. But, I would then respond saying, well, if it trips in February in a parking garage in Boston, you're buying a new sprinkler system, so yeah. It's really getting focused on the maintenance and trying to reduce failures of that air compressor is vital to the length of life that you get and the expenses associated with operating your fire sprinkler system. So, we've been doing everything we can to speak to service people about doing maintenance and getting it on their card to make sure that they're tracking these and following through with them. It's,
Well, especially with the 3-year trip test. Right? Because that's an NFPA 25 that you have to trip these systems every, I think it's 3 or 5 years. I forgot the cycle. I should know that. I'm on NFPA 25 and it's in the platform, but you're having to trip these. So all right, at that point, does the VCI have to, I don't know, do you have to replace all that once essentially you're flushing the system? So you're going to have to kind of re-up, and the same thing with nitrogen and air, you got to pump it back up. But, on these, the trip tests, I would assume that should be an NFPA 25, right? Because, and maybe I'll make a point to comment on that when it comes through the standard of when we're doing those trip tests, we got to take in consideration, hey, making sure it's up to the vapor barrier, right? When we put it in service again.
Yeah. It's the same, like I said, with nitrogen, when you trip the system, your nitrogen you've reduced to ambient levels. So then you're pumping it back up to the 98%, right? And that same thing with vapor pipe shield is that you lose actually not all of it, but a lot of it, right? A lot of your vapor barrier is gone. So once you reset the system, the nice thing here is that you don't have to do much else. You just fill the system back up with air, and the air compressor flows through our product and puts VCIs back into the system. So you're up and running pretty quickly. And there's not much else that you have to do because the the cartridges associated with vapor pipe shield are not event based. They expire, so you do have to change them every year. But like if the system trips, you don't have to change the cartridge or anything. So if you just if you just replaced the cartridge, then did your trip test, you're good. So it's just an annual maintenance thing, and that's where again, getting service companies to just kind of track the dates and just kind of follow through with their maintenance schedules is vital.
Yeah, and I think we're getting ahead of it in our platform. I think we've already added it to certain areas, so you can track essentially those cartridges dates and anything. I know it's not in 25 yet, but I'm sure people are tracking that on as they see these in systems or see these systems installed on Drive.
Yeah, I mean it's a constant battle. I mean, like I said, I know you are acutely aware of it, but I think we are too, just from a different side of the house, and that's just making sure that maintenance is done. When we get these calls and it'll be like, well, your air compressor failed in a year and a half. And we said, well, did you change the oil on your lubricated compressor? And they're like, what?
Yep.
And it's like, well, yeah, it's it's simple
it's
things
in
like that
now, right?
Yeah, right. Yeah, exactly. It's in 25 now. It's there, and the stuff in 25 was great. That's actually how I first started getting into, understanding how the standards worked and everything. It was Terry Victor, who's written a lot of 25, but he had called us up and just said, hey, we want to introduce some language for that. I think he recognized the same issue as you're saying, and it was probably around that same time frame. So very much could have been the same conversation. And he just said, hey, I want to put some basics in there about changing the oil, making sure the electrical's intact, making sure that it still does the 30-minute fill, that sort of stuff to ensure that this product is working. So we were all for that. So helped as much as we could. I was glad to get in.
And it's great and the standards seem to be catching up, and that's good. And yeah, I'm excited to hear more about it in the NFPA 25 committee meeting and how that gets through and into the next version 2029. Crazy.
Yeah, I think so. Yeah. Yeah, so it'll be adopted by 2035. I know. This is what talk about how long. Yeah, I know. Right?
Oh, God.
It's crazy.
Oh, there's so many jurisdictions that don't require air compressor maintenance right now. Because it was it 2017 or 2020? Well, I forgot what one it came in.
I want to say 17. I think it was 17.
And there's a lot of New York City still in 2014. Like they don't require air compressor maintenance.
Yeah.
It's wild.
Yes.
12 years behind. No, nothing against New York City. And there's a lot of jurisdictions that are
further behind.
The healthcare jurisdictions is still in 2011 for Joint Commission.
Are they really?
I don't know.
I didn't know that.
Yeah.
Wow.
Yes. Yeah.
2011.
So, 2011. Yeah,
it's always
national standard for healthcare.
Yeah, it's wild because as you work with these codes and standards, you're talking about what we need to do, and then it gets passed, and then you move on to the next thing, and you're constantly advancing things. And then I go and do presentations, and people will be like, "Well, since when did you have to do that?" And I'm like, "Since 10 years ago." And they're like, "Oh, our code's 15 years old." And it's just like, okay, well, I don't remember what you were and weren't supposed to do 15 years ago. So you'll have to tell me.
Yeah, monitoring and we have a good tool to monitor codes. So, but still, it's a lot. It's a lot. And, you bring up a good point is like future, what's coming next and how do we get some of the future technology into the codes faster? I sit on NFPA 915 for remote inspection and testing, and there's and that is pushed into 2572 for fire alarm and 13. But there's a pretty cool, part of the code there where it allows, remote monitoring of systems, and it doesn't need to be listed, right? And I think that's going to change just overall. I was hoping it would change 5 years ago, but it's slowly happening where we can take data. Like, we have so much data in SpecPoint about all these systems, but if we can get data, if we can get more of that from the actual systems itself, it would really help push the code forward, but also give like predictive analysis on how our systems are reacting. So I think, I know you guys are coming out with something. So I'd love to hear more about that.
Sure. Yeah. No. And I like what you said, because it's, getting a glimpse to how these mechanical systems are performing. I mean, we've always done this monitoring from the alarm side of the industry. But to actually kind of take a look at the mechanical side before it becomes an alarm, I think it gets into your predictive modeling of how these things are going to behave, and ultimately addressing problems before there's significant problems, which again benefits the industry from the standpoint of we're reducing costs associated with the maintenance of these systems, and increasing their long-term aspects. So the way General Air Products is working on that, we have a digital pressure switch that we came out with several years ago, and we've added some communication aspects to that. So it'll have a variety of ways to relay the behavior of your air compressor to a dashboard, where we translate that behavior into really dry system diagnostics. So, for example, if you're a facility manager and you have, let's say 20 hotels in an area that you're monitoring, or maybe probably more than that, 400 hotels in an area that you're monitoring. Right now, your dry system is put it on a schedule. Dry system maintenance is put it on a schedule, and we hope that we get to problems before they become major problems, right? And so it's a hoping for the best, and I'm sure that those people, they're just waiting for their next catastrophe. With a monitoring system like this on dry and pre-action systems, you can start to see, by way of what the air compressor is doing, that tells you there's something going on there that you might want to address. For example, like air compressors cycle, right? So an on and off is the air compressor refilling the system. And that should settle into like a regular pattern, right? It'll increase over time, but over long periods of time. So what this device will do is kind of measure and say, hey, your average weekly cycling for this dry system, right? Pressure loss and repressurization is like, 3 cycles a day. Then what'll happen is that you'll get an alert as a facility manager. Hey, this air compressor cycled 30 times today. Your air compressor is going to keep up with that. That's not a problem for the air compressor. But obviously something changed. Something happened in that system to cause such a drastic change in the behavior of the air compressor. So it's now worth sending somebody out to go take a look. Maybe you find out there was the HVAC guy was in the riser room, and maybe they turned something, or they opened it, with a valve or whatever, or some sort of leak developed. Anything like that would cause that to be an issue. So, or that issue to show itself. And now you can address it before, one, you cut into the life of the air compressor, or two, it becomes a much larger problem. So it's that sort of monitoring that we think is going to be really beneficial to facility managers and service providers and stuff to kind of keep an eye on dry systems, and get to problems before they're problems, and really kind of change the way that you approach maintenance of whether it's all your all of your customers and your service side, or all the buildings under your purview as a facility manager.
Yeah, you'll be able to tell. And I think this will be really powerful. I have facility managers for sure, but I think them learning, a lot of times they're putting it in the hands of that service provider, right? So I think, and they are, again, well more in tuned to sprinkler systems and suppression systems and anything fire. So And there's a monitoring component to this, right? The fire alarm companies monitor fire alarm panels and how that's getting back to the monitoring stations, central stations, and the fire departments, right? So there's that. Why can't we do that on the sprinkler side? We've never done that, and I think we're tapping into you're tapping into a good piece of the market where, ITM and service is big, and if we're able to provide a better solution to the end user, saying, hey, all right, this is how you rectify this problem, this leaky dry system, whether it's full out replacement, whether it's, hey, you got to change out this drive, whatever it is. With that monitoring piece, you're going to be able to at least point out the problem a lot better than sending a guy there once a year or every quarter. Like you're not getting any of that data. It's just like a tiny snapshot in time where if you're constantly monitoring it, you're going to have a picture of how it's doing. The last podcast we did was on an IoT device for electrical fires, and it's monitoring your voltage in your house. And it's super powerful just grabbing that data. Otherwise, you would never know that. So
yeah, I wanted to add to that too, because based on what you're saying, like, from the monitoring side, I mean, it really empowers you not just to be reactive when there's an issue, but also to kind of show your customer, hey, this is your leak rate on your system, right? I know from the years and years that we've been doing air compressors that most systems are far more leaky than NFPA 25 would allow for, right? Because NFPA 25 allows for roughly like a 30 PSI per day leak rate. And that would mean at most your air compressors running a couple times a day. And it's not uncommon for air compressors to be running a couple times an hour, which is an astronomical leak rate comparative to what's allowed in NFPA 25. And for these service contractors who have to go to their customers and talk to them about a sprinkler system that they don't really understand, that they may look at as a burden, you can now put data in front of them. It's not just me as a contractor standing there saying, here's what I think you should do. It's here's what the rules are, and this is the performance of your system. We've done this dry system diagnostic. How would you like us to address these things? Now you're talking from a much more, objective piece of information, as opposed to, it's, the contractor coming in telling you that you got to change this or change that. You can now prescribe, a solution.
Yeah, here's the data. And eventually hopefully this data changes the code, which again, we'll have to wait 12 years to have it get in there. But hey, maybe they'll put I don't think they would, but at least you can show it in the newer code if it does change. I think that data in Dime Labs is one of them that tests sprinkler heads. I think their data goes into changing the cycles and frequencies in the NFPA code and 25 code. So that will help change the code. So you need more data.
Yes. Yeah, I am excited about that aspect too, is as we start to get these out there, we have quite a few air compressors out there and we'll be getting more of these. So we'll be able to combine a lot of that data and give kind of industry related information as to what's going on in dry systems. So I'm interested to see, like you say, I mean, you get all this information and you can put it together, information from the performance of many dry systems. We can look at that as a whole and really go back to the industry and say, hey, this is like, we can say what we want, but this is what's actually happening out there. And here's, 1,000 or 10,000 dry systems that say that it is. And that has to be actionable. It might be our kids that deal with their action to it, but it'll be actionable.
Hey, it's something there. We got to collect the data first, though.
Yes.
Well, right. It's been great. I know we talked about, dry and pre-action systems downstream, right? It's a niche of a niche of a niche. But yeah. I think, again, it's one of the, the problems that we can solve in the industry. And I think we're, the last 20 years we're there. And I think the next, few will help that with some of the digital technology. So appreciate you doing what you're doing and coming on. Where can people find out about General Air Products and yourself?
So our website's a great resource, and I'm always proud to say that people can find the information they're looking for there, and we try to update everybody as far as kind of places we're going to be and things we're doing by way of LinkedIn. So pretty simple stuff, but we feel like we have enough reach there to let you know if you want to know. I understand that people have a very limited bandwidth for the air supply, but that's okay. We'll be there when you need us. So that's you can find us when you need us. And that's why I appreciate being able to come on here and talk about everything with you. It's, we try to get our message out there as much as possible that we're here to help and stuff like that. And so it's again, great catching up and great being on the podcast here.
Yeah, we'll have to chat again soon because I've been to your facility, your training facility, a couple times. Or initial time we hadn't had built yet, and talking about that. That's a big part of our industry that I really enjoy of what you've done and creating.
Oh, yeah, thank you.
That's a whole separate topic that I'd love to chat about. Maybe sure. Maybe once you're
you have to come in and we'll chat about it then. Yeah, it'd be cool to have you in.
And hopefully that device is out because I want to see it. And
I'll be excited to show it to you. Yeah, that'll be cool. I think we have a lot to talk about when we start doing that. I'm excited to see what you think.
Well, thanks again, Ray, and I'm sure I'll see you sometime this spring.
Absolutely. All right, Drew. Thanks a lot.
This was episode 94 of the Fire Protection Podcast, powered by InspectPoint. I want to thank Ray Fremont today from General Air Products for coming on the podcast and discussing everything niche inside of a niche of air behind dry systems, whether it's nitrogen, dry air, this vapor shield product, pretty cool stuff. And hopefully everybody enjoyed, and we'll see you again soon. Thanks.